first part. We're gonna ask you to guest lecture. We're not gonna do this.
I can stand up here. Should I just stay up here then?
Yeah. And then,
What is up recording?
oh, yeah.
You want me to
Like the getting Google.
screen share something different?
Oh yeah.
Yeah, because
just go to the-
everything that I do on here.
Can you go to
Shows
the,
up.
like get Eagle something now?
Huh?
Get Eagle.
What do you mean? Oh,
Like the download slide. Just skip a few.
Oh yeah. All right, guys. So just before we get started, if you don't already have Eagle, now is probably a good time to install it because that's what the workshop is about. We have instructions here, and momentarily we'll also like send out a Zoom link. But all you do is you look up Eagle download on Google, and you like click the first result, and you set your operating system, and you click download. It's really fast. You just like install it. Very, very straightforward. And since we're gonna be doing a live demo later, and we're gonna ask you to kind of walk through what we're doing with us, so we can all work together. Yeah, it's probably helpful to have Google so you can do it on your own laptop. Yeah, we're gonna wait I think like 2 more minutes just to see if there's any stragglers coming on. People who might be lost, bolster, yeah. That was people.
oh, interesting.
Hello, hello.
The announcements slide. Yeah, all right.
Oh, this one.
Oh fuck. All right,
What?
there's no tiny URL. I forgot.
Oh, the Zoom link. It's in Discord.
All right.
Okay, well, first of all, so as you guys are coming in, if you could do 3 simple things for us. Number 1, sign in here so we have a record of who's attending the workshops. Number 2, if you can't see that very clearly, or if you would also like to look at whatever's going on the screen on your own laptop, you should join the Zoom link. You don't have to type all of that in. If you go into the IEEE workshops announcements or links channel, you should be able to find that Zoom link. Number 3 is to actually download Eagle.
Is this mine or is this yours?
That's yours. So if you start downloading it right now, that way while we get into some of the background, you guys will have it downloading and setting up in the background. And when we actually start having you guys do some hands-on PCB design, you have everything ready.
Yeah, definitely. If you can't see clearly, here, and we're also screen sharing from our laptop, so you might be able to see here. All right, so then let's get started. Yeah. So welcome everyone. Workshop number 4, the last one of fall quarter. Thank you all for being here. This is the PCB design workshop. I'm sure you're all here to help us solve the mystery of the missing PCBs. And that's what we called it on the announcement. And once again, I'm David, fourth year EE, in case you forgot about me.
I'm Siddhant. I'm a second-year computer engineering major.
And today we have a special guest lecturer.
I'm Bradley. I am the 3rd year CE. I'm the IEEE project and lab manager, past micromouse lead, and done some PCB design. Yeah.
Yeah. So he knows a lot about PCB design, maybe more than us, maybe more than anyone. I'm sure he designs PCBs in his free time.
This is true.
This is true.
Yeah, so we've got Bradley here, so come share his thoughts with us.
Also, David, do you want to move closer to this computer so the audio picks up on the recording?
Yes, that's a very good idea. And announcements again, sign in, join the Zoom. After this workshop, there's going to be an ice blocking social at Jan Steps. I'll be walking over right after. So if you want to join me, you're more than welcome to. It's going to be a great time. And hope everyone is looking forward to Thanksgiving break. Hope you all have, a nice, relaxing, enjoyable break.
All right, so the first thing that you guys are going to need is to download EAGLE. This is going to be the software we use for PCB design. Okay, so you can either click on the link if you have the slides, or you can just Google EAGLE download, and it's going to be like the very first thing that comes up. You're going to select your operating system and download. It might make you make an account as like a preliminary step for Fusion 360, which is kind of a pain, but it's something you're going to have to do. Okay, once you have EAGLE downloaded on your computer, you're going to be able to launch it like it's a regular application, and you're going to see this format right here. You probably won't have any projects unless you've used EAGLE before and then deleted EAGLE and then still have the projects. So what you're going to do is just go under projects, and then you can make a new project. You can name it whatever you want. I would just call it like workshops or workshop PCB or something like that, simple. And then within the project, you would go to new and then click schematic, because that's what we're going to be working with for the first part of this workshop. We'll give you guys a couple minutes to download EAGLE, see if you guys have any issues with that.
Actually, just a quick poll. How many of you already have EAGLE installed, whether like for other things or?
Maybe half of you. Okay.
Yeah. How many of you are working on installing EAGLE right now?
Okay.
So we could probably, I think that's a small enough number. We could probably go through the slides.
Speed run. Should I continue? Okay, so while you guys are working on that, we're going to start going into some of the background onto PCB design. So some of you guys that are unfamiliar with what PCBs actually are, it's not PCP. That would be the chemical engineering workshop happening at the same time. But right now we have this board from the through-hole soldering workshop. So some of you guys went to that and you got this little blue plasticky thing and you were able to solder components onto that. That thing is called a PCB. So some further background, if we go further back, you guys, if you're an ops or in another project, you might have used something called a breadboard. So a breadboard is like a large plastic white block with a bunch of holes. The holes bread, because bread has holes in it, I guess.
Actually, it's a different, people used to like drill holes into bread cutting boards and then wire stuff into there. That's
I like my explanation better. Okay, so basically underneath these holes is going to be a like conductive wire, and basically it connects different pins together. So if you look at the breadboard over there, we're not going to go into too much depth here, but all the little black rows are connected, and then all the red and blue are like connected down the power rail. So if you were to connect two components and just put them so that their pins touch the same line, they would be connected. And so a breadboard is great if you're just prototyping or experimenting with something and just trying to get something to work. And that the reason for that is because you can easily plug in components and pull out components and replace them as long as they're through hole. The downside is that you don't necessarily always want to have a breadboard with a bunch of loose wires and through hole components. It's messy, stuff falls out. It's just kind of hectic, and you can like short stuff if like the legs of your components are touching each other. And we want something a little bit more permanent for some applications. And so for that, we have a printed circuit board. And you can think of this as like a breadboard that you have printed. Instead of having the default like grid sort of connections, you're defining your own connections between the pins. And breadboards or PCBs are customizable in that you get to pick exactly where you want your components to go, where you want the pins, so you can actually solder your components in, and how everything is connected. You can choose the shape, you can choose the color, everything like that. And then once you design it, you can just send it to a company like JLC PCB, and they will print it for you, and you can solder your own projects. Okay, before we continue, progress report from anyone still working on EAGLE. Are you having any issues, or are you just waiting on the download, or?
Is anyone still trying to download it right now?
Okay.
You said you're trying to reinstall it?
Yeah.
Oh, okay.
Okay, we still got a little time, so hopefully that works itself out, but let us know. Okay.
Keep going. Okay, so first we're going to get into schematics. Some of you guys, if you're in projects like Micromouse, have already been looking at schematics. And a schematic is basically a 2D diagram of a circuit that you're trying to build. And you're just going to plan out your components and what connections need to be made. And basically, this is a way to do it with symbols. And then you don't have to deal with like routing stuff or actually putting it on a board just yet. This is like your plan, basically, that you're eventually going to turn into a PCB. So as you can see here, we have some symbols representing components. We have a battery, some resistors, switches, and some diodes. And then there's lines in between the components. Those lines are representing the connections that you're going to make. So either if you were to turn this into a breadboard project, you'd have to make them go into the breadboard so that those two components are connected if there's a line between them. Or when we eventually turn this into a PCB board, we're gonna have to draw something called a trace between them. So here are some important schematic symbols. I'm actually not going to read through all of these, but for some of these components, the polarity matters. So there'll be a little like positive and negative sign, or something clearly looks asymmetric. That's a clue that the polarity matters, and you can't put it in either direction. So you need to be keeping track of what signal or net is going to go into what side of the component. So you don't want to flip it by accident if the polarity matters. Then we have these things called ICs, or integrated circuits, and they're components with more than like 2 pins or 3 pins. And on the schematic diagram, it's going to be like a rectangle or a square, and it's going to have numbers for the pins. But keep in mind that these don't really always correspond to what the actual component pins will look like. So you're going to have to look at the data sheet or look at like another circuit diagram really closely to figure out what pins are being connected where. So that way, when we go into making our board file, we have everything wired correctly. Okay, so here's some vocabulary before we actually jump into EAGLE to make your own schematic. So a net is going to be a connection between schematic pins. You're going to have a bunch of nets. Basically, like every new original line is going to be a net. And then a label will be a thing you can attach, and you'll basically be able to group connections together without drawing like a line between a bunch of them. So it's kind of like a macro of sorts. And then a part would just be any component that would go on your board. So that can include a battery connector, a resistor, an IC, a capacitor, anything like that that you would have to connect to your board would be called a part. So over the course of this workshop, we're going to be incrementally working on a circuit for a 5x5 timer PCB. And basically what this will do is you plug in a battery and the LED is going to be blinking at a certain interval. There'll be another LED on the back side of the board that's also blinking at the same interval. And that's going to be the board that we're designing. So whatever we're doing is a little bit more complicated than this because we're adding another LED. But here's the basic gist. Okay, so does everyone have EAGLE or is very close to finishing? Yes, yes, I don't see no's, so I'll just keep going.
Yeah, question?
Oh, go ahead.
Yeah, go for it.
Yeah. If you go into C in the EAGLE directory, that's where you see EAGLE 9.6.2. There's a DLL file called libEAY32. How do you name that to libEAY32.dll.dk? Then I try to run it.
Would you mind like posting that somewhere in the Discord so people can reference that in the future if possible?
I'm not into this sport.
How-
Also, this has happened in the past with some where like rusty phones selling, so I think we do.
Okay.
I'm gonna try and
Okay.
get
Okay. For the sake of the
Or how,
recording.
alternatively,
Yeah.
We just, as long as we put it in
Yeah.
the slides eventually.
yeah,
Yeah.
alternatively, if you could just join the Zoom and type it in the chat and then we could all see, it'd probably be easier.
If you guys look at these slides after the workshop, we'll include the fix onto it, make it easier.
So it's the.
Okay. All right, works. Perfect. MVP from one of our audience members. Dang, love to see it. Okay. So if you're all able to open EAGLE now, hopefully you are, and you're able to open a new schematic, this is what you're gonna see. This is the EAGLE UI. And you know, on first glance, it's a lot to take in. There's a lot of, you know, tools and functionality that EAGLE has, but there's three main parts of the UI that you should focus on. The first one is at the top. There's a command line, and that's where you can type in specific commands, which we'll get into later. On the left side, we'll have our toolbar, which has all of our functionality with when you're moving stuff or you're laying down nets or you're adding parts, things like that. And in the middle is your workspace. That's where you actually, you know, drop your components and you make your circuit. So this is the EAGLE toolbar, which is on the left. I'm just going to go into some of the common commands that you might be interested in later. The first one at the top is going to be group. This is for if you're moving multiple components together, you might find it helpful to group them. And that way you don't have to kind of move them separately, they get lost, just group them. Next up, move. This is pretty self-explanatory. If you want to move a component around, you should select this and then click your component and just drag it around. Rotate, if you want to rotate your components as well, 90 degrees, 45 degrees, whatever. Add part. We're going to get into this later, but you know, if you want to add resistors or capacitors, ICs, your 555 timer, if you want to make an actual circuit, you're going to have to add parts from somewhere, which you'll do from here. Next, the connect tool. This will connect the nets that Siddhant was talking about before. If you've taken a circuits class before, the net is basically your wire. So you got to wire your parts together, obviously, to create a complete circuit. And after that is label. Again, Siddhant talked about this just before. If you have multiple nets with the same name, for example, you have multiple connections to ground, for example, or multiple connections to power, it might be more helpful to just label it as ground, and that way you don't actually have to connect everything and have a bunch of lines crossing your screen. After that, name and value. When you put down your components, you can give them a name, for example, R1 for your resistors, and you can give them a value, for example, 10,000 or 10K. And then finally, copy, delete. You know, it does exactly what it says on the box.
Put the slides in.
Yes. And so importing components, we're going to do a live demonstration of this, so you don't have to pay too much attention to what's on the slides here. But basically, if you want to import a component that is like your custom component, or you found it online somewhere, there's a few steps you have to follow to do it. Of course, there's a lot of default components that EAGLE comes with, but yeah, if you looked up something online, you got to import it. And so Bradley
Yes.
is going to do it right now.
All right, so it's demo time. this is going to be a little bit rushed just for the sake of time. Normally you'd like spend a lot of time making sure your schematic is good, that it actually does everything, you'd like check it, test it, do things like that. But we're just going to do this kind of quickly just so you guys can hopefully see the whole process. So I am going to share my desktop instead. All right, can you guys see all this? So
Yeah. Also, if you want to follow along with whatever parts Bradley is using, there's a link in the Zoom with these slides. We skipped over the actual like part descriptions for the sake of presenting, but if you want to follow along, you can find those in the slideshow.
yeah, so start off, we're going to create a new project. Let's just call it like IEEE workshop. And then we're going to add a new schematic. Okay, so as I mentioned before, this is the schematic window you start off with. Since we're doing a 555 timer circuit, I feel like it makes most sense to start off with the 555 timer itself. So we're going to go into add part. We're going to do 555 timer, 555. And one thing you can do is you can use these wildcards, which are the asterisks. Note that essentially matches any character. So this will find 555 as a substring within any name in the included EAGLE libraries. And you can see like there's a lot of miscellaneous things in here. We can like figure out what we're looking for. I did a little bit of looking beforehand. I really like this one. So this is the part we're looking for. This is all good. So this is the 555 timer. You can hit OK or enter just to like put it in there, and then we're just gonna go ahead and place that. So now it'll like try to place another one, but to get out of that, you can just hit escape once to get back to the screen, or escape twice to get back to here. So another thing in the schematic is, sorry, yeah, do you have a question? Did you search star 555 star? Yeah, so you need the stars to do wildcards, so it'll match as like, because if you notice this says NE 555, so a star at the start will basically say anything that starts with something, and then star at the end will be ends with something after 555, and then that'll help you find something that's within. Yeah. Oh, Zoom link. Are you in the IEEE Discord? It should be in workshops announcements or the main announcements channel. Okay. So actually, I'm gonna pull up the schematic over here. Okay, so here's the schematic we're going off of. You can see we need 3 resistors. Oh, sorry. Yes. We're gonna go over that in a second. So
if you have the slides pulled up, they're on there.
I'm on the Zoom, but I joined after.
Oh, no problem.
Okay. Any other questions before we go into adding some other miscellaneous parts? All right. So I'm gonna go add some resistors because those need to be added. So I'm gonna do here star resistor. And you can see there are a bunch of miscellaneous things. Let's find, I like this one. So this is just like, this library has a bunch of standard ones. You have like the European symbol, the US symbol. And I'm just gonna find a standard through hole component. Also, side note, see these bars next to the components? Those show you if it's like a very well used part. So like this bar indicates that this part is well used. It's used by a lot of people. So I'm going to assume that that means this is what I'm looking for, because I'm just looking for a standard through hole resistor. So I'm going to do this. And then when you're placing a component, also another thing is if you right click, that rotates the component for you. So that's just a fun little trick to help make things easier to move around. So you can see that I'm just going to place these generally where they need to go. One needs to go from power to pin 7. So I'm just going to place one here for that. One needs to go from 7 to pin 6/2. So I'm just going to do this for that. And then we need to come out of pin 3 to an LED. And I'm actually going to place, I'm just going to start with placing one in order to place that there. So now that we're done with resistors, I'm going to hit escape, get back to here. does that part make sense? Does anyone have any questions about placing resistors? Okay. So you notice when you press escape, it takes you back to the add part screen, so you can select another part you want to add. So another one is, let's say this capacitor. So there's a 1 microfarad capacitor. So I'm going to search. And oh, look at that, right? Huh? Okay. There are a lot of capacitors in here. I am going to do this 1 microfarad. I believe it's a 1 microfarad capacitor. I'm going to do a surface mount one. We'll go into this later. This is just for more diversity in the parts we use. So here is a surface mount capacitor. Huh? Okay. I'm just going to add the rest of this part just to make it go faster. Okay. LED. Should I just I can also just use the one I have pulled up already. Okay.
Go through the measurements here and work off.
Okay. I need to find this LED. Oh, okay, here we go. It's one of these.
That's fine. As long as it's schematics and little.
Yeah, okay. Okay, so LED, then supply voltage. We're going to do this by, let's just do 5 volts up here. This here, this here. Okay, so these components are placed. We're ready to do wires. So I'm just going to wire everything up. This one goes to here.
Yeah, so here he's basically following the
Oh,
schematic.
yes.
And the schematic was supplies, and obviously like you would have it in front of you if you're actually doing this. And that's how he knows like what's the wires for.
Okay, so you also asked about importing footprints. So you notice there's no power source, and that's because we have a very specific power connector. So the one we're using is a JST connector. You can, the website I like to use is called Snap EDA. They have a bunch of things that people have made. So once you find the part you want, such as this JST connector, sometimes they'll also like link it on DigiKey. You can hit download symbol and footprint, and then you can select EAGLE. So what this does is this just downloads it onto your computer. And then once you have that, you can go into your computer, go to wherever EAGLE is. So that's, for me, that's documents, EAGLE, and then libraries, and then just drag this library into that folder. So it's available for EAGLE. Then go to library, open library manager. Then if you go to available and you can do browse, it should show up there as you download it. So you can see I just downloaded this and it is right there. So we take this, hit use. And then now when I go into add part, I can search for JST or maybe B2B. And there it is. It's right there. It is available for our design, just like that. And then I can hook up, actually, I'm going to use the copy tool to wire this up to power and ground. Okay. I think that's mostly, is there anything I'm missing on here? Okay.
Is anyone confused about like what was going on just now?
That's fine.
Yeah.
How do you know what parts to use? Like,
So that, when you're designing a circuit, you'll like figure out the like values and components. Here we're going off the reference schematic, which is the 555 timer circuit. So this here is where we get our parts. If you're designing your own, it's just like what you're designing essentially.
Yeah.
Yeah, if you're looking for, yeah, so if you're looking for like which parts to use, normally if you have some sort of like, oh, I want to use LED, you can go to something, I want to go on ED, you can search for like LEDs, and there's a little checkbox that you can check, and it'll like only show the ones that have EDA models. And if you check that, like all of them pretty much, if you click any of those, you can download the print and put it onto your schematic. You could get them that way.
Yeah. There's this thing right here, EDA CAD. Also, side note, you should have your volume on, microphone. Mind turning that off. I'm hearing a little bit of feedback on here.
Okay, thanks.
You guys want to let me turn on do not disturb. Okay.
Okay, so we have a cheat code for you guys, because there was a lot of parts that you had to pick out and place onto your schematic. And the focus of our workshop really is taking the schematic and putting it onto a PCB. So you can go to this website, and then, or it's a link to a Google file, and you can just download like a completed schematic, and then we can work from there. So I'll give you a couple minutes to do that. You can just download it, and then like from your whatever your file browser is on your computer, you can just open with EAGLE.
I'm gonna do that
Okay.
here real quick. Oh shoot, wrong button. Projects. There we go.
So as Bradley just like quickly demonstrated, you can just download it and then go into your like projects folder for EAGLE and just drag it into that, and it should show up. Do you have a question? Give them a second.
I think we could, yeah, anyone having any issues finding that file? Because we're gonna be working off that file. After this, we're gonna be laying out our schematic and making an actual board out of it. Yeah, what's up?
Does that have to be imported, like, if we're using libraries, if we have
Yeah.
You can later, but for now, it'll still work.
Okay.
Yeah, so
Yeah.
you can deal with that.
In
after.
case you're wondering what the library is, it's probably this one that Bradley downloaded in front of you guys. If you didn't download it, then like, oh,
But it still says that like
You know, it'll still work.
if it doesn't work, we can.
Yeah, we can get that for you later. Yeah.
Okay, so we'll now talk about actually converting our schematic, or basically our laid out plan for our circuit, onto a physical board. So here are some things we need to do from start to finish in order to have like a working PCB in your hand. One of the first things you're going to have to do is select the size and shape of it. This is like one of the biggest constraints you can have would be like mechanical constraints. If you want a PCB to do a certain task, or you want it to be a certain size, making your like actual PCB in EAGLE that size to begin with is probably one of the most important first steps. Otherwise, if you lay it out in the wrong shape or it's too big, it's going to be like a lot of work resizing it and putting it back where it needs to go. The next step would be to actually place your components onto the PCB shape that you've created. And when you're doing this, you would want to think about considerations for each component. For example, if you were doing micro mouse and you had to place IRs, you probably have a particular location in mind for them on the PCB. Obviously, if you put them onto the middle of the PCB or something like that, they're not really useless or useful. So certain components have like considerations on where on the board you would put them. And so you should also keep that in mind. Some orientations, if you flip or rotate components around, will make your life easier or harder, depending on how everything else is oriented. So you should also play around with rotating components. And lastly, you also want to think about the aesthetics of your board. Do you want it to be symmetric? Do you want a lot of empty space on one side? Stuff like that is all important considerations. After you have all your components placed onto your board, you're going to actually run traces. And as David mentioned, these are basically equivalent to wiring components together. And then the things with traces are, since they're like basically just wires, you can't overlap them like intersect them, because that would be like a short. Traces also have like a width, so you can, for example, have thin wires and thicker wires, and certain traces should be like larger than the bare minimum, and we'll get into that a little bit more. And then there's also something called a ground plane that we'll also get into. After that, you're just going to run like a check, polish, and then you can order your board when you're done. Okay, so should we give them time for this? Speed run. Okay, so
Bradley will, walk through all of this step by step. So we're just giving like a general overview of, what you can do. And later on, these slides will be available for reference if you want to check back.
okay, so you can basically start with your schematic, and then you can click switch to board, and then it'll say you don't have a board, so you create a new board. And basically, EAGLE will remember what components you have and basically how you connected them on your schematic file. And so all of your components will show up, and there'll be little lines to remind you how everything should be connected. The dark space in the middle is going to be the board that you can like play around with later. Okay, so we'll go through some vocabulary that wasn't included in the schematic portion, but it's important for PCBs. PCBs are multiple layers. You could have a top, yeah, top, bottom layer. So actually, we're not going to go through all of these. You can read them on the slide shortly. Okay, so basically, there's multiple layers on the PCB. You can flip the PCB around. It's not just like one circuit. It's like multi-dimensional. And you can actually run traces on multiple layers. That way you can avoid intersections. So you can have a wire go over another wire or under another wire. And so EAGLE will have different colors to show you what layer your wires are on or your traces are on. Okay, so again, traces are basically your wires, and they correspond to the nets that we created in the schematic. So you can't intersect them because they're a unique connection between two specific pins. And you want to bend them at 45 degrees and not 90 degrees. And you also want wider traces. Those are better than smaller traces, because if you have a smaller trace, it's like basically more resistance. And you basically have to find a compromise between having a large trace, but also making your board nice and compact. There's also some traces that should be wider, and you want to avoid making it stretch all the way across the board. And here are some of the considerations right there.
Yeah, and after that, after traces, we also have polygons, which are basically continuous pieces of copper. And imagine a trace, but now like instead of a wire, it's just like a whole ass like piece of copper. So everything connected to that polygon will have the same voltage. So if you're connecting everything to a single source, for example, you're connecting all of your components to ground, a polygon is a really good tool for that, because you can just designate that polygon as your ground, and that way you don't have to connect everything to a specific source. You can just like run it into the polygon and it'll work it out for you. Next, vias. These are also really important. They're basically holes in your board, and it's it might be unclear why you would want that. And so it's because, as Siddhant mentioned, traces cannot overlap on your PCB. Again, your traces are literal, pieces of copper running through your board. And if they overlap, it'll create a short. And so sometimes you're gonna need another way to connect two pins. And vias are basically tunnels in between two layers. So if you're kind of blocked off from connecting to a pin, you can use a via, and you can go underneath the trace and around it. And that's how you can connect to your components. So this helps you kind of connect hard to reach components. But you should also like try not to rely too much on vias. There's a reason for this, but you should challenge yourself to try to work everything out with as few vias as possible. Next up is your pads. If you saw the PCB that we handed out at the soldering workshop, the metal areas around where you stick the pins in, those are called your pads. That's where you actually solder your component in. And you should remember that when you're designing your PCB, in the end, you're going to want to solder these components into your board. So try not to kind of cram all of your components into one corner, that's going to be really difficult to solder, and you'll feel very sad later on when you're actually trying to get it to work. Finally, the Selfscreen. Selfscreen is basically you can write text on your PCB, and this text can be anything. It can be helpful things, for example, a part name like R1 for your first resistor, R2 your second resistor. It can also be your part value, for example, 10K for your resistors, 1 microfarad for your capacitors, and it can also be the actual footprints or orientation. For example, on the PCB at the workshop, we had examples of all 3 of these. Generally, try not to allow text to overlap. It'll look bad. And just keep in mind that the Selfscreen text is going to be white. Finally, once you've done all of these, you've laid out your PCB, you've done everything, you're going to want to do the design rule check, which basically is how EAGLE tells you that it thinks something is wrong. And you definitely want to make sure you run the DRC after you think you're done, because if EAGLE thinks something is wrong, then there's a chance that your board might not be printed properly. And then when you receive it, you'll just get some dead boards that don't work. And then you'll be really sad. So that was a lot. And because of that, we're going to have Bradley kind of try to walk through step by step all the components we mentioned and try to create an actual working PCB. So everyone, if you could kind of follow along, that would be really nice. Bradley.
Cool. All right. Also, I'm going to try to do this kind of quickly. Hopefully it works well. All right. Starting off, we're going to switch to generating a board, pressing this button. It's going to ask me if I want to create it. I'm going to say yes. And here's our board. You can see it's pretty big. This is the board. These are the components. So I'm going to start off by just resizing the board a little bit. So I selected the move tool, and I'm just going to change the dimensions a bit, make it a little bit smaller. You can zoom in. Actually, that's way too small. All right, we're going to go. I have a design in mind, and I'm just going to go through what I'm thinking. So I'm going to try to make a little bit of an aesthetic board. So I'm going to start, just going to do a rough layout at first of like where I want the components. So like the important ones for me are the LED, the 555 timer, and the power. So you can see all these little yellow wires are the air wires, and those show you the connections that you need to make. So you can see like this one needs to go here and here. And it looks really confusing. And when you're laying out components, one thing you want to try to do is organize these air wires, so you have the fewest crossings. So you can see like these ones cross right there. So I'm going to rotate it 90 degrees, and that looks a lot cleaner.
Yeah, there's a question.
Yes. So make sure to select this move tool on the left side. And then there's also in the part itself, you see this little X or this cross. That is the part that you have to click to actually move a component. So EAGLE's kind of finicky about like where you have to click things. So make sure you're clicking on that X. Any other questions? Okay. So just gonna keep placing these components. You can see like trying to make as few air wires cross as possible. I'm gonna do this one here. I want to put this LED on the back side, and one thing you can actually do to make that happen. So this is the info thing. You can use that and then select something and see a lot of information about it. So if you actually do mirror, then that switches to the back side, and you can see that it's on the other layer because the pads turn blue. So everything red is on the top layer, and everything blue is on the bottom layer. There's a lot more layers than that. You can see them all here. The main ones are like top and bottom, and then dimension if you're messing with the dimensions of the board. So I'm just going to continue moving some things around. I'm going to put the LED, let's put it here. Move this over a little bit just because why not? So another thing, so here's the capacitor that you guys saw in the schematic. So this one, I believe this is another thing about capacitors too to keep in mind is that capacitors should go really close to the components they're associated with. So for this integrated circuit, this 555 timer, this capacitor is meant to go between pin 1 and 2, and you want to put it as close to there as possible. This other one we stuck in there, C3, this one's called a decoupling capacitor. I'll leave that more like project leads to explain that, but essentially what it does is it smooths out the power supply. That one's also really important to put right next to your components because that's meant to smooth out the power supply for that component. So this is something that is specific to the component. And you'll see, so this is I want it right next to the VCC pin. So I'm going to put that right there for now. I'm going to do a little bit more organization in here just to get everything aligned. Let's see, let's put this. Oh, okay. Yeah, so another thing you can do, so it's really hard to get the scale of things on here. Like if you place something like right here, you could be like, oh, these two components, they're separate. They'd be easy to solder. That is false. These components right here would be very hard to solder. And if you want to get a sense of like how big your board actually is, EAGLE has a dimension tool. So you can go into here, you can see this dimension thing, and then that lets you essentially like, you can either click on a component and it'll tell you the dimension of that, or you can click a point and then draw a line and then place that. And if you hit info, you can check, make sure the units. So we're in millimeters. So this is 5.18. Oh wait, no, that's the different one. So this is 33 millimeters long. If you want, you can look more into that. Also, another thing on the subject of units, this grid thing is another fun thing to play around with. So this sets the snap grid of everything. So you can see a mil is 1/1000th of an inch. That's like, I won't get into that. But you can do this to set like whether you want grid lines. So I actually kind of like grid lines. So I'm going to turn that on. And you can see that like this is everything. All the components that I've been placing have been snapping to this grid that is set by this grid thing. And that helps you with like keeping things aligned and stuff like that. Let's see what else stood on. Am I missing something else to talk about? Okay, I think this is a pretty good layout. We're going to start laying out traces. So the trace tool is right here. These traces, right now they're air wires and I want to route them. So I'm going to do route air wire. You can see the width is here. I'm going to increase that width because 6 mils is really small. Let's just route a few of these. You can see doing that here between like resistors, stuff like that. Do it like this. Okay, so, slow down. Okay. Oh, okay. Okay, so what should I do? What should I cover right now? One thing. Okay. So I'm gonna mess around a little bit with the board shape a little more. Generally you want like square board shapes, but you also can play around with that a little bit. I'll leave that as an exercise to you guys for now, but I'm just gonna make this a little bit more compact. Just like this. I'm gonna move it. So remember this move tool is the same move tool as the schematics. You can select a bunch of things and move it. I was trying to keep it centered at the origin. Okay, what next? Let's see. So I have a few more. Sorry, yes, question. Oh, good question. So there's this info thing that you can use to get more details about it. So use that, click on the LED, and then to move it on the bottom, you click this mirror button. Any other questions? Oh, this info, it's this I. Well, not the I, but the letter I. Good. Okay, so let's remember David mentioned vias. So building off of the switching to the bottom, these are surface mount components. So this is a surface mount component. You can tell that because the pad is only on the top layer. So the red is the top layer. The green are the things that go through the board. Those are like the pads that go through the board and like can each reach either the top or the bottom layer. So like all these green circles are things that go through the board, and all these squares that don't have that are only on one side. So like connecting things top to bottom with these pads is actually not an issue. So if I'm routing an air wire and I want to switch to the bottom layer, making this connection actually works just fine because I can just route it straight from there and get that to go everywhere I need to go. However, I can't do that with surface mount components because you can see if I try to do that, connect this to here, you may think that's connected, but it's actually not. And you can actually see that if you, no, you can't. So in order to connect these, you need a via. And there's two ways you can do that. You can either use this via tool and place one right there, or what I'm going to do is I am actually going to delete this trace. Do route air wire. And then while I'm routing it, I'm going to switch the layer to the top layer. And you can see that it automatically puts a via in there. So when you click to place it, it'll switch back to the top layer. And you can place that going from the bottom layer to the top layer. So now that that's there, you can keep routing things. Also, another thing, if you'll notice, I haven't been routing any of these ground connections. And there's a fun trick we can do. Generally, you use it for ground connections. So remember, do you guys remember polygons? That fun little thing that just connects everything? So I'm going to create a ground plane. That's a very common thing to do in a PCB, to create, basically make an entire layer just connected to ground. So every component can connect to ground on that layer. So here we're going to go into the Polygon tool. You can click that. And then just basically select the edge of the board. Why is that not? And you can mess around with it later. But once you connect it, it'll ask you for the signal name. I'm going to say ground. And you can see that there is an outline. So in order to actually have this pour, and like when you pour a polygon, it's like implementing the copper that actually is in that area. So in order to make that happen, there's this button right here called the rat's nest. This is actually like a kind of like a reset button or a refresh. What this will do is it'll pour all the polygons. It'll reformat the air wires so they're going towards their closest component. So you notice when I press this, then all of this red appears. Remember, the red is the top layer, and you can see that it connects ground, all the ground things right there, and makes everything work well together. However, now when I'm designing my PCB, I have this giant red thing right there, which is annoying. If you want to get rid of that temporarily, you can either use this rip up tool, which is you can use to like rip up wires, polygons. You can just like click that. Actually, you just click that one, rip up all visible polygons. Or if you're feeling lazy, we haven't used the command line yet. So one command that I find really helpful is rip up, which is for the rip up tool. And then if you do @, that'll get rid of all the connected polygons, and you can go back to seeing everything as you saw it before. Let's see what else. Okay, here is another thing that I kind of noticed. Turns out I don't actually really like the location of this resistor. So I'm going to delete a few traces and play around with this a little bit. So I'm actually going to use the rip up tool. I can't delete them one by one like that, or I can do rip up and I can do connected copper. And this will delete like a whole stretch of traces. So like everything that's all in one long line, it'll delete everything there. So I'm going to take that, move this one over here, do that, and let's rip up this one too as well. And you can see it's going to take, oh, that's connected copper on the same layer. Now it should, oh, it didn't. I think that's because there's a component in between, but actually you can see that when I change this to here, I'm going for an aesthetic design, and this just, in my opinion, looks a little bit more aesthetic. Another thing about traces too, so you notice that this trace automatically routes at 45 degrees. You could be tempted to do something like this, where you have a 90-degree angle. 90-degree angles are bad. Try to avoid them when possible, and try to make them as gentle as you can. So like 45 is a good angle. Just avoid this and instead try to get something like this. Let's see, what else? I'm going to continue routing a few of these wires, and then we can get into some more fun stuff. Just to have this here, and then this goes to, oh, another thing. So you notice how it automatically like selects a route. If you right click, then it'll change the default angle or position that it goes to. So if I want it here, you can see I can right click and it'll choose a different default position. Okay, so I need this power and I need this power. Okay, so now at this point, all I have left are ground connections. So when I do rat's nest, I believe I have made, oh, okay. So I believe I've made all my connections. Just to make sure, one thing you can do, remember we mentioned the design rules check. Under tools, you can go to DRC, that stands for design rule check. We're gonna run this just to make sure that we connected everything. So once you get there, you can go to this, you get this screen and you can hit check. So it'll give you a little bit of a summary. Ideally, you should have no errors. Here, we have an error. You can click on it, you can see what it is. So there's a few air wires in here. Let's start by looking at this one. You can double click, it'll highlight. And it looks like this ground is not connected. So, so if you notice, this ground is on the bottom layer, but the ground plane is on the top layer. So this blue pad actually is not connected to the top layer where all the ground connections are. In order to fix that, we just need to do a little trace. Actually, let's do this with a via. We're going to add a via. I'm going to put that here. And then we're going to add a trace connecting ground. Oh, I need to name this. So I'm going to actually go to info here. I'm going to go to name, and I'm going to call this the ground via. And it's going to ask me if I want to connect it, and I'm going to connect it to ground. So from here, I am free to take this pad, connect it to there. And now if I run the DRC again, you can see that we're down to 2 errors. So let's see, another air wire here and another air wire there. Okay, so get rid of that polygon. I'm going to route this wire. And then now I need to route, where does this one reach? Oh, this needs to go to pin 7. Oh, I think I flipped this. Okay, so this is actually not what I wanted to do. We need a better position for this. So I'm going to switch some of these around. I'm actually going to switch these 2 resistors. We want to do this. How am I doing? Go faster. Oh, sorry. Okay. Let's see. Okay, I forget I found a really good position for this. BCC. Let's actually do it this way. Okay, so I'm gonna do this, I'm gonna do this, and now I want to try to route these traces. I take this one to here, this one to here, this one to here, and this one to, let's take it to there. Okay, so another fun analysis tool that you can use. Say I want to see how my ground connections are. One thing that can be really tricky with ground planes is they can get really cut up. So if I do show ground, you can see that like if you're tracing the path from the power connector to all the grounds around the board, if you want to get to here, it's all connected, but like if the only paths from this power to this LED is to go around the side of the board or around this way. So using like the show and then a net name is a really good way from the command line to see what is happening in your board. So ideally, like you want your plane to like be able to flow through the middle. I'm going to ignore that for now. We have a nice one that we made, and we can send that to you guys later. But there is one more thing I want to show you. So I'm going to write this up. So the last thing you normally do in the design is you mess with the Selfscreen. So like if you see all this, all the gray stuff is all the text that will be printed on your board. It looks pretty messy right now. Like you can see this is really long, this is really small. These are all like at all kinds of angles, things like that. So what I'm going to do is I'm actually going to get rid of some of this text that's not necessary. So I'm going to like, you don't need to know like what type of JST connector it is. So I'm going to get rid of that. You can make them all uniform size. So like say I like this size, this is size 39. Let's actually make that 40. You should be able to select all of it. Oh wait, I'm going to select just the names and place layer, which are the components like the Selfscreen layers. I'm going to right click, go to properties and set the size to 40. Oh, that actually just changed one of them. Yeah, you can also like make sure to play around with the Selfscreen because like the Selfscreen is the stuff you will actually see. So you can like move stuff around, like move the labels around, move the names around, rotate things so they look nice. Do stuff like this, move this, like 1K ohm resistor, put that all nice. And if you want some more fine granularity, you can go to this grid. You can change the snap grid to be something finer. That'll allow you to be a little bit more precise with how you move things. Make this bigger. It's 40. Make it a little bit, the line's a little bit less thick. Sweet. Does anyone have questions about anything I've done so far? Oh yeah, definitely. So there's this Polygon tool here. And what you do when you draw a polygon is you just draw the vertices of the polygon. So you start here, you like pick another one, you pick another vertex, you pick another one. And then when you finish it, when you go back to the one you started on. And once you do that, it'll ask you for a signal name. You can type in whatever you want to be connected within that polygon. I'm going to delete that. Any other questions? I know this is pretty fast and a lot of information. Yeah. Siddhant, do you want to? Well, does that anyone else have a different question? I think I saw some. Yeah. So a polygon, one thing to like know what's on each layer is like generally everything's color coded. So when I pour the polygon, you can see that the polygon shows up in red. So red is everything on the top layer of copper. So here you can see like this is showing the top layer of copper, and that polygon is in that layer, like are going around all your signal traces. So like So you can see like here, there's actually like some space between the polygon and the trace that connects power. So that means these are not connected. So like, remember when I do show ground, you can see that like all this stuff that's not highlighted, those are different traces or those are different gaps within the PCB itself. Any other questions?
How do you see, like, how do you, I don't want to say this, but like, how do you get that? It's like, I actually have a red element on that.
Oh, so you can either hit this rat's nest button and that'll pour the polygon, or if you want, let me actually just get to where you are. You can actually just type rat's nest into the command line and that'll do it for you. Anything else? Should I show them the like example one that we made?
you can.
So I played around with this a little bit before, and I made a sample board. Let me save this. Oh, this is the wrong. So this is another example board that I made earlier. You can see like components are laid out somewhat nice, like the silk screens or some of these overlap. So I want to like fix this one.
Show them how to use like the checker tool.
The DRC.
Yeah.
I think I already did. Yeah.
that.
Okay. So yeah, generally like this is like what you want to go for. You can see there's like no real 90-degree angles. The silk screen doesn't really overlap. This one's on the bottom, so that one doesn't count. And then yeah. Any last minute questions? I know that's kind of a lot and a little bit disorganized, but essentially the best thing you can do for PCB design is just like make something, play around with it, and familiarize yourself with all the tools. Yeah. Oh yeah. So what you can do, so use the info tool or right click a component. This properties tab should pop up, and then it's this mirror button. So this mirror, it mirrors it either on the top or on the bottom. Does that make sense?
Also, a few people have had this issue and it might help. Like if you can't select the component, like if the plus sign isn't there, if you go on the left where it says types, it has a bunch of like types of things in EAGLE. And if something is deselected, it won't let you click on it. So make sure that devices is selected. Otherwise, you won't be able to click on any device components.
Yes, good point.
Yes.
I think that's a Fusion 360 thing. I know it's like some software, it's the other Autodesk software. It's not in EAGLE itself.
There is an option in EAGLE that I don't know if you can give you access, but you can actually convert it over to 60 model.
All right. Anything else?
You get back to the red down command on the inside.
Oh, okay. So you can do this rip up tool, and then you can do all visible polygons, or in the command line, you can type rip up and then at, and then a semicolon. And that will, so if I do rat's nest, if I do rip up at semicolon, that'll get rid of it for you. Other questions? Okay, wait, I'm going to. All right.
Okay. So you guys should feel free to keep playing with that on your own time. If you're in a project that requires a PCB design, obviously that's going to be a great way for you to learn how to actually do the PCB design. If you're not in a project, then I encourage you to just like finish up the 5x5 circuit we gave you. If you want someone to look over it, just make sure everything looks good. You can come into the lab during lab hours, and I'm sure someone there will be willing to like look over your PCB, make sure that there's no like glaring issues. So if you were doing this on like a personal project, you basically would have picked the components based on like what components you're going to buy for that project. And then once you have your PCB design, you would order the PCBs from a vendor like PCB Express or JLC PCB, and then you can solder your components on, and you have your working project. Any questions about any of the material we've covered so far? All right, awesome.
All right, does everyone feel comfortable using Eagle? Like you would open it and kind of know what to do? Question mark? A little bit? You know?
Do you feel comfortable Googling the right things to lead you to the answer?
That's the
Okay.
important part.
Okay, yeah.
It
And
comes with practice and Googling.
yeah, like, you know, PCB design, it makes no sense the first time you do it, and it makes no sense like the first maybe 5 times you do it. But I think the best way to learn is just like practice on some easy circuits. If you're ever in the lab, ask someone to help you, or watch someone do it themselves. So yeah, it's very confusing. And
Yeah, so after the workshop, we will put the slides in the workshops channel. We will also put the schematic that you guys started with, and also the board that Bradley has right here. Or it's not screen sharing anymore, but the board that we just ended on. So that way you can see like what it would look like at the end and play around with it.
yeah. Okay, so everyone, this is the end of the content for today. Make sure you sign in at the link we have. We do have a Kahoot for you if you guys would like to stay. And after this, we're going to be walking over to the IEEE ice blocking event. So if you want to stay for that, you're welcome for that as well.
Screen share this.
Oh,
Oh,
I feel like everyone's.
feel like people want to-
And if you're leaving, everyone, thank you so much for coming out. We hope you learned something today. Hope you thought it was helpful.
By Saturday, I will post it.
Yeah. And feel free to stay for Kahoot, ice blocking, if you want to ask any questions. If you want to sit in the chairs, they're very comfortable. It's not recording. Anyway. Good.
That's on Siddhant's computer.